Okay, we're talking about isotonic, hypertonic, and hypertonic solutions with respect to red blood cells. Dialysis is a type of osmosis where, because of the kidneys not functioning properly, there's a buildup of uric acid and other ions, waste products that need to be removed from the blood. All right. And therefore, what you're doing is taking the impure blood and pumping it through a dialyzing coil, which is a semi-permeable membrane. And the dialysate would be something that would draw out all these impurities, uh, including excess water. Okay. And so that would flow out into the dialysate. The purified blood is then pumped back into the patient. Okay. So it uses the principle of osmosis. Indicate if each of the following solutions is isotonic, hypertonic, or hypertonic. All right. So normal NaCl should be 0.9%. This is higher, so it is hypertonic. Normal glucose level should be 5%. This is 1%, so therefore that's hypotonic. Normal sodium chloride should be 0.9%. This is 0.5, so it's hypotonic. 5% glucose is normal, so that is isotonic. When placed in each of the following, indicate if a red blood cell will not change, undergo hemolysis, undergo crenation. Right, 5% glucose is normal, so it won't change, isotonic. 1% glucose, that's hypo, so it should kind of swell up, undergo hemolysis. 0.5% NaCl is again hypo, so it should swell up, hemolysis. And then 2% NaCl is way above the 0.9%. So water should come out of the cell, so that would be undergo crenation. All right, so to summarize, we looked at solutions. We talked about the two components of solutions, solute and solvent. And then we looked at solubility, which is the amount of solute in a given amount of solvent or solution rather. And we looked at what is the maximum amount of solute that can be dissolved into a certain amount of solvent. That's a saturated solution. Electrolytes can be strong, weak, or non. Non means they can dissolve into the solvent. However, they do not dissociate, they do not form ions, or and they don't conduct electricity, whereas strong electrolytes will separate out into the cations and the anions, 100% dissociation, giving a strong signal with a light bulb. Weak electrolytes form some ions, but mostly they remain intact as molecules. So you can get a slight light bulb signal with a weak electrolyte. They conduct a little bit of electricity. Now, we talked also about equivalence, and when they are making electrolyte solutions, IV solutions, that the amount of positive charges must balance the amounts of negative charges. Types of solution concentrations can be either mass, gram over gram, or mil. volume by volume, or gram over mil, or molarity, which is commonly used, moles over liter. And then these percent solutions or molar solutions can be diluted. You can take a stock and dilute it further. And then you can use these percentages and molarities as conversion factors to go from moles to volume, or grams to volume, or grams of solute to grams of solution, and mil of solute to mil of solution, and so on. Okay. Then we talked about the colligative properties of vapor pressure, freezing point, boiling point, and osmotic pressure, when we dealt finally with osmosis, define what osmosis is, looking at the semi-permeable membranes, and especially looking at how osmosis applied to the RBC, red blood cells. Okay, so that's the end of chapter 9.